5. Partial differentiation. Suppose you consider area of a triangle which is a function of height of the triangle and base of the triangle, and you wish to evaluate rate of change of area of the triangle with respect to height, treating base as a constant. Next time you wish to evaluate rate of change of area of the triangle treating height as a constant, that is, you wish to evaluate rate of change of area of the triangle with respect to change in base. Then you have to use the concept of partial derivatives. Suppose you have z as a function of x and y, where x and y are the independent variable and z being dependent on x and y, we call z as the dependent variable. Derivative of z with respect to x treating y as a constant is known as partial derivative of z with respect to x, and it is denoted by dou z upon dou x or dou f by dou x or f suffix x. We have dou z by dou x equals limit h tends to 0 f of x plus h comma y minus f of x y upon h. From the numerator of this expression, it is clear that y is treated as constant. By the expression dou z by dou x, we mean that we evaluate rate of change of function z in the x direction considering there is no change in the y direction. Now we have derivative of z with respect to y treating x as constant, which is known as the partial derivative of z with respect to y, denoted by dou z by dou y or dou f by dou y or f suffix y, which is mathematically expressed as dou z by dou y equals limit k tends to 0 f of x comma y plus k minus f of xy upon k. From this expression, it's clear that x is treated as constant and there is change in the y direction. By dou z by dou y, we mean that we evaluate rate of change of function z with respect to y or in the y direction considering there is no change in the x direction or treating x as a constant. Dou z by dou y and dou z by dou x are known as first order partial derivatives of z. Geometrically, we have z equals f of xy defines for all pairs of points xy which belong to the area of xy plane, there will surely exist a value as per the relation z equals f of xy. Thus, for every pair xy, we will obtain an z value as well. Thus, we have values x, y, z lying in this space, and thus z equals f of xy represents a surface. Dou z by dou x is the slope of tangent drawn to the curve of intersection of surface z equals f of xy and the plane y equals k1. Since y is treated as constant, it is a plane which is parallel to zx plane. Similarly, we have dou z by dou y is slope of tangent to the curve of intersection of surface z equals f of xy and the plane x equals k2. Since x is treated as constant, the plane is parallel to yz plane. That is, just like we studied, derivative of y equals f of x is tangent drawn to curve y equals f of x. We have dou z by dou x and dou z by dou y are also slopes of tangents.